Hi, hello. Good morning all of you and welcome to our Utalent channel. In this video, we will discuss the real number. This is the first chapter of class 10. I will explain it very simply so that it is very easy for you. We got some idea of real numbers in class 9. You can watch the video. I will give the link in the description box. Now, I am giving a roughly idea of real numbers. Real numbers are the numbers that can be plotted in a number line. This is the flow chart of real numbers. Now, all the counting numbers such as 1, 2, 3, 4, 5 and so on are called natural numbers. Natural numbers are denoted by capital N. Now let's draw a circle to represent natural numbers. Now the whole numbers includes all the natural numbers and 0. So draw a circle around the natural numbers. This circle represents the whole numbers. Here whole numbers are denoted by capital W. Now integers includes all the whole numbers and negative integers. Now what is negative integers? -1, -2, -3 and so on. These are all negative integers. So here draw a circle around the whole numbers. This circle represents the integers. Integers denoted by capital Z or capital I. Now, what are rational numbers? Numbers that can be written as P by Q, where Q not equal to 0 and P and Q are co-primes. That is, there are no common factors between P and Q. Like 2. 2 can be written as 2 by 1. This is the form of P by Q and denominator not equal to 0. And also 2 and 1 are co-prime. So 2 is a rational number. Rational numbers includes all the integers and fraction or decimal number. So draw a circle around the integers. This circle represents the rational numbers. Now the real numbers includes all the rational numbers and irrational numbers. Now what are irrational numbers? Numbers that cannot be written as P by Q are irrational numbers like √2, √3, √7, etc. Now we will draw a circle with rational number and irrational numbers. So this circle represents the real numbers. Real numbers denoted by capital R. So this is the recap that you already know. Now we will discuss some new topics. What we will study in this chapter? Basically, we learn about Euclid division lemma and Euclid division algorithm. Other side, we also learn about the fundamental theorem of arithmetic. In this session, we will learn how to find HCF and LCM. So let's start. Euclid's division lemma. We are puzzled by the name, but it is not as difficult as the name. Once you understand, it will be very easy for you. Let's see what it said. For any two given positive integers a and b, there exists unique whole numbers q and r such that a equal to bq plus r, where r is greater than equal to 0 and less than b. Now what are a, b, q and r? Consider a simple example of division. 15 divided by 7. Here 7 twice are 14 and remainder is 1. Here 15 is a dividend, that is A. 7 is a divisor, that is B. 2 is quotient, that is Q. And 1 is remainder, that is R. So, what Euclid division lemma is saying? That is, dividend equal to divisor multiply quotient plus remainder, where remainder R is always greater than equal to 0 and less than divisor B. Hope all you understand. Now we will see what HCF and LCM are. HCF means highest common factor and LCM means least common multiple. That means the LCM of two or more positive integers is the smallest positive integer that is evenly divisible by both given positive number. Let's look at an example. Find HCF and LCM of 6 and 10. First, we will do the factorization of 6 and 10. So, here 6 can be written as 2 times 3 times 1 and 10 can be written as 2 times 5 times 1. So, LCM of 6 and 10 is 2 times 3 times 5 times 1, that equal to 30. And HCF of 6 and 10, here we see what is the common factor, that is 2 and 1. So, HCF of 6 and 10 is 2. Here we remember that the product of HCF and LCM is equal to product of two given numbers. Okay. How to find HCF by using Euclid's division lemma? First, we look at the steps. Step 1. Apply Euclid division lemma to A and B to find whole numbers Q and R such that A equal to BQ plus R, where R is greater than equal to 0 and less than B. Step 2. If R equal to 0, then HCF of A and B equal to B. And if R not equal to 0, then apply the Euclid division lemma to B and R. Step 3. Continue the same process till the remainder is 0. At this stage, when remainder equal to 0, the divisor will be the HCF of A and B. Now, let's look at mathematical example. Find the HCF of 27 and 129 using the Euclid division algorithm. How to solve? Here the larger number is 129 and smaller number is 27. Here smaller number will be your divisor and larger number will be your dividend. Got it? You will divide it 4 times. So 4 times 27 is 108. So here we are getting remainder as 21. Here we can write by using Euclid division algorithm 129 equal to 27 multiply 4 plus 21. Here remainder is not 0. So now divisor will be your dividend and remainder will be your divisor. Okay, got it? You will divide it 1 times. So 1 time 21 is 21. So here we are getting remainder as 6. Here again by using Euclid division algorithm we can write 27 equal to 21 multiply 1 and plus 6. Here remainder is not 0. Again using the same process, divisor will be your dividend and remainder will be your divisor. You will divide it 3 times. Here 3 6 are 18. So we are getting remainder as 3. So we can write 21 equal to 6 multiply 3 plus 3. Still remainder is not 0. Again using the same process, divisor will be your dividend and remainder will be your divisor. You will divide it 2 times. So 3 twice are 6. So here we are getting remainder as 0. Now remainder is 0. So here divisor 3 will be the HCF of 27 and 129. Okay, got it?